white dots you see here are radionuclide stations. 80 such stations are part of the CTBT global alarm system to detect nuclear explosions. Like this one. A nuclear explosion generates radioactive particles and gases. These radionuclides are dispersed by the winds. They may travel long distances from an explosion. Radionuclide stations are deployed to detect them. These stations are built in exposed areas as they rely on the wind. In an air sampler, radionuclide particles get trapped on a filter. Once a day, the filter is removed from the sampler and compressed. It is left untouched for 24 hours to allow non-relevant radionuclides to decay. The compressed filter is measured in a detector for another 24 hours. The result is information on the radioactive particles found on the filter. The detection of underground nuclear explosions is more challenging. Such explosions also generate radioactive particles and gases, but as you can see, the particles cannot escape from the underground. We have to rely on the radioactive noble gases as evidence. They seep through the underground into the atmosphere and are dispersed by the wind. Half of the radionuclide stations can detect such radioactive noble gases, in particular xenon. The detection process for noble gases is different. Air is collected as before, but only the gases are trapped. Xenon is then isolated and measured. Here you see everything again. Radioactive particles and gases arrive at a station. They are being sampled and measured in separate processes. Resulting data are sent via satellite link to the CTBTO in Vienna for further analysis.